Okay, in this topic, we are going to talk about the prerequisites needed for learning about linear, compound, and absolute value inequalities. So what we're going to cover in this section is set builder notation, interval notation. So I call that set builder notation and interval notation, and also linear equations involving multiple steps. So let's go ahead and take a look at set builder notation and interval notation. So set builder notation can be pretty wordy. So here we want all x values greater than or equal to -2. Can you see we want -2 and we want everything bigger, okay? So set builder notation says the set of all x, in other words, all x values that you have, such that x is greater than or equal to -2. Interval notation uses boundaries. So here we have a left bound and a right bound. I'm going to write that just here. There's our left bound and here's our right bound. It is a set of numbers with boundaries, okay? So our interval notation says our left bound is -2 and we want to include it. Comma means moving to the right, and then we will stop at positive infinity. Okay, so interval notation uses left bound, comma, right bound. And then you will decide here if you have brackets or parentheses, okay? Let's give this next one a try. Here, you can see we need all x values less than 3. So we didn't say less than or equal to 3. So set builder notation is the set of all x such that x is less than a -3. And interval notation, let's talk about our boundaries, our left bound and our right bound. So here our left bound is -infinity, and we always use parentheses because we can never stop and have an endpoint, comma, moving to the right all the way to -3, and we don't want to include -3. Okay, let's take a look at number 3. Here, we want everything bigger than 3 and less than or equal to +1. So we want all x values I'll start with greater than. I mean, there's lots of different ways you can say. You could also use the word between. Let's try that. Between -3 and 1, but we want to only include 1. And maybe I should write including 1. Because it's closed. A closed point. So set builder notation is the set of all x such that x is between 1 and -3, but also equal. I didn't write that right here. Very good. There we go. So just keep in mind that we have this equals because we wanted 1. Let's go to interval notation. The left bound is -3 The right bound, comma, moving to the right is 1. We want to include 1 and we don't want to include -3. So interval notation is really nice for the in-betweens when we have a set of numbers in between two numbers. Okay, let's go ahead and take a look at objective number 2. We will solve each equation. So I'm just going to bring this over here. We are solving for that t, so I am going to add 2 to both sides. And we have 1/2 t equals 5. I'm going to multiply both sides by 2, and we come up, and we come up with t is equal to 10. In number 6, we have an x term on both sides. So the variable x is in both, so we need those together on the same side. So I'm going to subtract 24/7 x from both sides. And now, if we take a look at that, we have 3/7 minus 24/7, and that's a -21/7, and that's a -3. You can do this on your calculator. Let me show you, because we really don't want to waste a lot of time working these easier addition and subtraction out. So 3, and you can use this alpha y equals and get fractions if you want. You don't necessarily have to do that. But 3/7 minus 24/7, and it'll give you -3. Okay, so now here we have -3x minus 5 equals 7, and we will add 5 to both sides, and we have a -3x is equal to 12. And, of course, I'm out of room. Move that up. Move this up just a bit. I really can't move that up too much, okay? Because it looks funny. There we go. Okay, and now we will divide both sides by a -3. And we have x is equal to -4. Whoops, I went from 4 to 6. I should have gone from 4 to 5, but that's okay. So now we see we want to add 9 to both sides. And we have 2k is equal to 1. We will divide both sides by 2. And we have k is equal to 1/2. Looking at number 7, we are going to subtract 11/12 from both sides. So we end up with -5/9 w is equal to, now let's do this in our calculator. And again, I know that you all can do these by hand, and I think that's fabulous. But I think that we don't have that kind of time in here. So we have 23/36 minus 11/12. And you could have used alpha y equal. Okay, now we have a decimal, so let's press math and number 1. And we get a -5/18. Now, we're going to multiply both sides by a -9/5. And we end up with w equals, now look, I've already got -5/18 in my calculator. I can say multiplied by -9/5. And we end up with a 0.5 and that is 1/2. So I hope I've inspired you a little bit to use this calculator for those steps. Those are not college algebra steps. Those are just, multiplication and division and reducing fractions. Okay, let's go ahead and look at these next few problems, okay? So we are going to distribute this 1/2 and distribute this 1/6. So 1/2 times 2 is 1. So half of 2 is 1. So we have t minus 2. We still have our plus 3. 1/3 of 6 is 2. And 1/3 of 3 is 1. Now we did forget this c here. So this should say 2c. So here we have c plus 1 equals 2c plus 1. I'm going to subtract 2c from both sides. And I will have a negative c plus 1 equals 1. And now I'm going to subtract 1 from both sides. See if I can make this a tad bit smaller. And sometimes students struggle with these problems. They don't know how to answer these. So just look closely. So 1 minus 1 on the right-hand side is 0. And if you multiply both sides by a negative 1, you are going to get a positive c is equal to 0. Okay? So sometimes getting 0 for an answer can be bothersome. Okay, we cannot add fractions in here until we have common denominators or there's a new method. What we will do, and I guess we'll go to number 9 and work in order. So what we will do is we will multiply the entire equation by the LCD. The entire equation. That means every term. So here our LCD is 3. So we are going to multiply every term by 3. So we have a 3 times 2x plus 1 over 3 plus a 3 times x minus 1 over 3 equals a 3 times 5. And these 3's cancel. These 3's cancel. So we have a 2x plus 1 plus an x minus 1 equals 15. So 2x plus x is 3x. And 1 minus 1 is 0. So those will cancel. And then we end up with 3x equals 15. And we will divide both sides by 3. And we have x is equal to 5. So that turned out pretty nice. Okay. None of our denominators, none of our variables were in that denominator, so we were okay. We'll be addressing that later. So that was number 9. Let's move to number 10. So here our LCD is 5. So we're going to multiply everything in this equation by 5. So we have 5 times 4 minus 4y minus 2 over 5 minus 5 times y plus 4 over 5 equals 5 times a negative 3. So we have 4y minus 2 plus y. Now we have to be careful because right here, let me get a highlighter, we have a negative. So we have to be very careful with that negative. So that is actually going to be a opposite of y plus 4, negative 1. Let's go ahead and distribute that negative. And then, of course, we have some like terms. 4y minus y is 3y. Minus 6 equals negative 15. And we're going to add 6 to both sides. Let's see if that's a little bit better. And then we have 3y is equal to negative 9, dividing both sides by 3. And we have y is equal to negative 3. Okay, let's go to number 11. Here, our LCD, let's change colors a bit, is an 8. Now, where did I get an 8? This denominator is 4. Whoops, that is a pencil. This denominator is a 4. This is a 4 times a 2. So the LCD, we each have a 4. So I only write it once, and then we still have a 2. So that's where we get the 8. Okay. So now we're going to multiply everything by an 8. So we have an 8 times z minus 7 over 4 equals an 8 times 6z minus 1 over 8 minus an 8 times 2. Now, as you can see, these 8's canceled, but 8 divided by 4 leaves a 2. And I should probably write that a little darker, that 2. Okay? So now we have z minus 7 with a 2 in front of it. Is equal to 6z minus 1 minus 16. Let's distribute this 2 and combine the negative 1 and the negative 16. Now, let's go ahead and add 14 to both sides. And we have 2z equals 6z minus 3. We will subtract 6z from both sides. And we have a negative 4z equals a negative 3. And divide both sides by a negative 4. And we have z equals a positive 3/4. We are getting there. Let's go ahead and look at number 12. Here we have an LCD. This is 4, and this is just a 3 times a 2. So we do need to use to drop down into 2's. So what 4 and 6 have in common is a 2. So they each have 1, 2. So it's going to be 2 times, and then we have a 2 and a 3. So that LCD is going to be 12. So we will multiply this entire equation by a 12 times 2x minus 1 over 4 plus 12 times 3x plus 2 over 6 equals 12 times 2. So a 12 divided by 4 is 3. 12 divided by 6 is a 2. So we have 3 times 2x minus 1 plus 2 times 3x plus 2 equals 24. Now we'll distribute the 3 and the 2, kind of running out of room here, but we have 12x plus 1 equals 24. See if I have any room. See if I can move this smaller and over a bit. And now I don't have too much left. Now I'm going to subtract 1 from both sides. So I have 12x is equal to 23. And we'll divide both sides by a 12. And we will have x is equal to 23 over 12. I'm going to go ahead and square that off just so that you can find that. Okay, let's look at number 13. I have 7y minus, and I'm going to distribute that negative 3. 7, I'm going to distribute the negative 1. So I will combine my like terms before I do anything. So I have y minus 15, just one y equals a negative 3 plus 10y. We will add 15. And we have y equals 12 plus 10y. Subtract 10y. And here we are again, out of room. And, oops. Here, we now have y minus 10y equals 12. We will factor. We will not factor. We will combine. 1y minus 10y is a negative 9y. And then we will divide both sides by a negative 9. And we have y is equal to negative 12/9. And if you put that in your calculator, that's a negative 4/3, or if you reduce that yourself. Maybe I should not put that there. So I'll just maybe do a light circle, because you couldn't really see the other. Okay. Let's raise that up a bit. Okay. And the last problem we have is number 14. And we can see that we do have something to distribute first. So let's take a look. And of course, I won't use those equals on the outside. So let's just start. This is 4 plus 2 times 8 minus 6 minus x. So you want to take care of the inside first. Equals negative 2x plus 2 minus 4 plus x. Let's get our like terms together. And here we have 4 plus 2 times 2 minus x equals a negative x minus 2. We still have to distribute that 2. And we'll combine these like terms. And we have an 8 minus 2x is a negative x minus 2. So now we just proceed with, I'm just going to go ahead and subtract 8. And then we'll go ahead and add x. And then we will multiply both sides by a negative 1. And we have x is equal to a positive 10. Okay, and that concludes this section.